In today's video, we are going to be talking about another type of transformation called dilation. So when you think of dilations, you think of something that dilates is your pupils. Your pupils in your eyes, they dilate, right? The more light that comes into your pupils, the smaller they become, and the opposite goes as you have less light, they become bigger. So dilations is basically enlarging or shrinking the size of a figure, still keeping the same shape, but just making it bigger or smaller. So we have this dilation in this problem, and we're going to find the scale factor. We're going to see how much is it dilated. So the rectangle on the right is a scaled copy of the rectangle on the left. Identify the scale factor. All right. So we have this rectangle became enlarged from this rectangle. So in order to do that, I have to see, okay, the longest side of this rectangle is 24. The longest side of this rectangle is 6. So how does 6 become 24? You multiply 6 times 4 to get 24, right? And that should work with this one too, right? 4 times 4 is 16. So the scale factor would be 4. Now, this works awesomely when you have numbers that are part of your times tables that you know off the top of your head. You might have other different copies. All right. So, how about this one? The right triangle on the right is a scaled copy of the right triangle on the left. All right. So, I take a look at this and I look at this. So, it looks like this became smaller. All right. So these are the corresponding sides of this triangle, these triangles, and these are the corresponding sides of the triangles. So we have, how does 12 become 6? What do I have to multiply 12 by to get 6? Now, if you don't know that off the top of your head, you could use your calculator. You take the dilated image first, this number first, right? The 6, all right? And you divide it by the original figure. So you do 6 divided by 12 and then reduce. The fraction is 1/2, right? And you could double check 5 times 1/2. Is that going to give me 5 halves? Let's see. 5 times 1/2 is 2.5, which is 5 halves. So that is my scale factor, 1/2. Okay, let's look at another one. The longest side on this one is 18. The longest side on this one is 9, right? So it looks like it became smaller. So 9, you would take this one, 9 divided by 18, which should be 1/2 again. Yep, 0.5, which is 1/2. All right, let's take a look at one more. Okay, right here. So this one became smaller, and this one actually is a square. So they're all corresponding sides. So it became smaller, so you take the dilated figure, 17 thirds, and you divide that by 17. So 17 thirds divided by 17. Let me see. I'm going to try to do it this way. That whole thing. Make sure, like, notice what I did before. Okay, you can't just do the slash symbol because it'll only take the bottom number. So when you do that, it just takes the 3, but you want to take the entire fraction. And maybe another way to do that too would be to put the 17 thirds in parentheses and then divide that by, what was it, the original 17? So that's what I would like you guys to do with this one. All right, you put the fraction in parentheses before you divide it by the original length, which is 0.3 repeating, which is 1/3. All right. Submit. All right, let's look at some tougher ones. Not so much with this one, right? So this one became smaller, dilated. Okay, smaller. Let me just delete all this good stuff. So you take the dilated figure divided by the original figure, 63 divided by 81. And to get that, reduce it, it's 7/9. Okay. This one became bigger, 12 divided by 7. I don't think you can reduce that fraction, but let me double check. Nope. Just the same exact thing. So it's just 12 divided by 7. All right, let's take a look at another one. That one's pretty simple. There's got to be a tougher one in here somewhere. One with fractions, maybe? No. All right. So I don't think there's one with fractions with this one, but I want to do one more with fractions, so we'll go back to the other one. Oh, there's Sonic. So let me try to find one with a fraction in it. Here we go. All right. So this one became bigger. So we have 95 over 4, and we're going to divide that by 19. I'm going to put that in parentheses. Divide that all by 19. And you get 5/4. So that would be your scale factor. Awesome. All right. So we talked about finding the scale factor of a figure. Okay. Now let's take a look at dilating points and see what you do with that. So we have the image 3, -5 after it's dilated by a scale factor of 5. All right. So when you know the scale factor, what you have to do is take this scale factor, this 5, and multiply it by each of the parts of the coordinates. All right. So 3 times 5 is 15. -5 times 5 is -25. So this image became, well, not bigger since the point it stayed the same, but the coordinates, the numbers in the coordinates became bigger. Okay. Let's look at this one. Scale factor of 1/2. So you have to multiply 1/2 by 0. Anything times 0 is 0. 1/2 times -6 is -3. I don't want to do another half one. Let's go. There we go. Now, if you don't know what 4 times 1/4 is, again, use your calculator. 4 times 1/4, which is 1. -8 times 1/4. So I'm just going to change that to -8, and then you get -2. So, do one more with a fraction. Not 1/4, though. Others, there we go. 1/3. -12 times 1/3. -12 times 1/3. It is -4. And 9 times 1/3. So I'm just going to change this to a 9. And you get 3. Bam. Okay, so that's it for today's lesson on dilations. Remember, a dilation is when you're shrinking or enlarging a figure, keeping the same shape and the same dimensions. And the scale factor is what you multiply the original figure by in order to get the dilated image. All right, so that's it for today's video. Thank you for watching. And always remember, whether you're solving for X or Y, always give math a try.